Shane wanted to, or his initial question is, so let me actually take, let me open up, well, let me just open up this. Okay, whatever. Okay, and let me blow up the text a little bit. Let's see, change fonts. I think you would have to put it within a set of quotation marks. Well, let's find out, right? I've never actually thought about that. Where did Vice go? Where's Vice? Why do I not see it? You know, that's the right one. I just don't see the window. Let me minimize stuff. Yeah, I think I managed to break it. All right, hold on. Yeah, okay. Well, c'est la vie, right? All right, so let me go back to Vice in a minute, but let's talk about the tokenization process, right? Because this I think you guys had some questions here. Oh, okay, we can do Zoom. Okay, so what is it that we have to do in order to tokenize this, right? Well, several things. What's the very first set of bytes that are going to be in the program file? 01, 08, right? That's the same for every basic program ever. Okay, so that part's easy. Then after that, you're going to have basically, you're going to be like, some of this is, do you want to think of your file as being sort of a string, or do you want to think of it as being a character by character, byte by byte kind of thing? Okay, part of that's going to depend on exactly which language you're going to work with, slash how you're going to open files for processing. Okay, now in Python, right, there's the open command, right, where you can open a file and it'll be by default in the directory that your Python program is in. And then you need to specify how are you opening that file, for reading, for writing, binary or not, right? That just depends, right? Okay. And then there's also the write method that allows you to write to that file stuff, okay? And how exactly you're going to write to it is partly going to depend on how you process and how you're thinking about it. If you're thinking about it on a character by character basis or as a string basis, then it may look a little bit different, okay? But there's also in Python, there's what did we say? It was read line and read lines, plural. Okay, two different methods that go with the file object for taking data out of the source thing, and then that creates like a string or a string object that allows you to, um, um, get one line at a time from the source file, for example. Okay, so if I got one line from this source file, it would be a string that has the 10 space, print, etc. Okay, and what is it that I need to construct out of this? Okay, yeah, so let me actually do, let me put this here, and this is maybe not the best tool for it, but I'm going to use Excel. Okay, just I want to be able to put things in boxes. Yeah, I know, right? That's sort of like what it's designed for. Okay. Um, all right. So if I have the thing 10 print, okay, so let me, for the sake of the discussion right this instant, let's ignore the fact that we have to put the 01, 08 at the beginning of the program, because that's a given no matter what. So just just ignore that part and let's deal with the rest of it, okay? Okay, so I need to turn 10print into a sequence of characters or sequence of bytes, and let me just shrink these down so we've got some space for it, okay? And what do I need to transform that into, okay? What has to go first? A pointer, then a line number, okay, and then all the rest of the stuff, okay? So the first two blocks are going to have a pointer. Okay, now, do I know necessarily what the value of that pointer is going to be? Not yet. Okay, now we can deduce it, right? It's probably going to be something, something followed by 08, right? Because their programs are pretty short. But the exact values we don't necessarily know yet. So let me go and just think of those as being placeholder values, okay? Then I need to do the line number. Now, in this case, what is the line number? 10, okay? And so if I were to read in that line from my input file, then it's the symbol 1 followed by the symbol 0 as a string, right? But what do I want out of that? I want the numerical value, correct? Okay, if I've got the string that holds the characters 1 and 0, how do I turn that into a number? So join in what sense? Like join the two characters into a single string? Yeah, okay. So if they're already a single string, obviously you don't need to do the join part, but you've got a string that has 1 followed by 0, okay, as letters or characters, and you want to convert that to a number that has the value 10. What function does that? Yeah, string to int, okay, or whatever it's called in Python, right? So you guys remember in 241, what did you guys write? You wrote this program, but in assembly, that would take in a string of numeric symbols and spit out the number that that matched, right? So, okay, every language has a built-in routine to do this, whatever it's called, just use that. Okay, so you get 10, okay, as a number, and what do I need to put in the line number spaces? Yeah, 16 bits, okay. What are the first 8 bits going to be? The low 8 bits, which in this case would be 10 and 0, okay? Low byte, high byte order, okay? Now, for our programs, because they're all relatively simple, I think you could safely assume that this byte is going to be 0, because what's the biggest line number you could use if you only had a single byte for it? What's the biggest thing you could do with 8 bits? 255, okay, which would be FF. Right? And of course, your line numbers aren't getting that big, but yeah. No, I'm not going to be diabolical. Okay, so what I mean here is in my source code over on the left, we've got 10 print, right? And you can assume, right, for sake of just doing this particular problem, maybe I'll change it to 15 and 25 when I test your stuff. But I'm not going to change it to 256, 356 just to be a jerk. Okay. Well, maybe I'll do that for yours, Rippy, and fail you and make sure you don't graduate. All right. Well, the door's right there. Don't let it hit you on the way out. Okay. Yeah. So, right. Okay. So I guess just for sake of simplicity here, you can assume that the second byte there is going to be zeros. Okay. Yeah, because like, and this is sort of the annoying thing, right? If you were going to do this in C, and this is of course why I would prefer to work in C for something like this rather than Python, is because in C, uh, well, okay, in Python, if I just say a equals 10, right? It's a number. Is it an int? Is it a float? Right? And to some extent, do you care? No. Okay. Um, so one of the nice things, right, about Python is that the data types are not picky, right? If you, like, for example, had a number that was 10 and another number that was 2.5, well, it's probably going to assume that the 10 is an integer at first, but then if you add it to 2.5, it's just going to convert the data type for you and you don't really have to worry about it and everything's cool. All right, that's nice, right? Because it makes it easy for beginners and also easy for anybody, right? You don't have to be picky. Okay, but I think in a case like this, I would actually really rather know the data type, like for certain, right? And be able to work with it and know, am I encoding this as an 8-bit integer, which is a char in C, as a 16-bit integer, like an uint or an int 16 or something? Um, excuse me. Right. So, yeah, but anyway, uh, that number, like, I'll let you guys assume that the second byte is going to be 0, so that your line numbers are up to 255 and no bigger. And for simple programs, that's totally adequate, right? Okay, so the line number can be computed immediately because we know what it is coming in from the source thing. It's the stuff at the very beginning, okay? Now, is there a space after the line number in my source text? Yeah, there is. Does there have to be? No. Okay. So if there's a space there, um, then I need to, respect that. And if there isn't, then I also need to respect that. But that's okay because the space, right? What is a space? Yeah, it's a character. And what is that character number? Yeah, 20. Okay. All right, so that's the space, no big deal. All right, and then we hit the word print, okay? Is that a token or is that a word that needs to get converted to a token? Print. Yeah, okay. So print is a word that needs to get converted into a token, okay, because it's outside of quotes, right? So, uh, and this is where it's going to can depend on how you want to think about this. So let's say that you've already dealt with the line number and you've already dealt with the space, okay? And what's left in the line would be print space hello, right? Is print the beginning 5 characters of that string? Yes. So we know the word print is here. Is that need to be tokenized? The word print, anyway. No. Then yes, it needs to be tokenized. Okay, so print would need to get tokenized as 0x99, right? And so I would need to put that value, that byte, in this position. Yeah. The line number? It puts one in. Okay. So the line number and the thing, and that makes sense, right? To code it that way, because it makes it kind of where to look in the string. So I guess what Rippy is saying is if I put this in, the program file would have the space there. Okay. So let's just, for the sake of being nice, you can assume that there will be a space between the line number and the first actual letter, okay? Because I'm not trying to be a jerk here, right? Right, because I mean, Rippy's point, to Rippy's point, right? Like I think you guys will get the same the same learning will happen if you deal with me being nice versus me being cruel. It's just me being cruel would be more of the same thing, right? It's kind of like, well, let's say, for example, I've taught you how to multiply multiple digit numbers, and I give you a 4 digit number times a 3 digit number. Am I really testing anything new if I give you an 8 digit number and a 6 digit number, other than your bookkeeping ability? Not really, right? So it's the same process. Um, yeah, okay. So we've got our token for print, followed by what in this case? A space, okay, which would be, and notice, by the way, that, um, so let me actually just do this. Oh, I forgot the quote, sorry. Oops. Okay. Everything after the token is just whatever's there. Okay, in this particular case, right? So it's just whatever the text is that's left. Now, in general, is that a guarantee that there's only one token per line? No. Okay, and what's the example of this? Yeah, if you do a colon, okay, what did the colon allow you to do? It allowed you to put two commands on the same line, basically combining lines together, right? Um, And then, so there might be a token after the colon, right? The other thing we saw, although with the example program we were looking at last time, we wouldn't have to worry about that for this, is the equal symbol, like when we did a for loop, the equal symbol got tokenized, right? And so if I did like for I equals 1, 2, 10, then there were actually three tokens there, right? 4, equal, and 2, like the word to. Okay. Okay. So you're going to have to be careful with the string processing, but remember, your tokenizer only has to be able to handle the basic file that you guys turned in for Tuesday, right? And very minor modifications thereof, right? So like me tweaking the line numbers a little bit, okay, is essentially it. Otherwise, right? Because again, I'm not asking you to write a complete tokenizer that could take any basic program and do it, right? That's a much bigger thing. It's worthy of being done, but it's way bigger than a just quick assignment. Okay, and in particular, to do it properly or semi-properly, right? You'd actually want to do a little bit of lexicographical analysis, okay, to sort of pick apart a given line into substrings and sort of be smart about how you carve it up. So, for example, to Rippy's point, right, anything that's a quote that starts with a quote and ends in a quote, you can think of as a single unit because nothing inside that is going to be tokenized, right? Whereas everything that's not in a set of quotes, you have to worry about because there might be a token there, there might not, right? There's line numbers and so on. Yeah.
Which is why I was asking, can you print the quote? Because
The quote symbol.
One that makes it a lot more annoying because if you can't just split it the quote. Because if you can't get the quote,
then you can't split it at the quotes. Yeah.
Because like if you usually split that, you can basically split it into several substrings that are split the quotes, and you can know which ones are in the quotes and which ones are not.
Right. Yeah. So I think if you can't type a quote as part of a quote, but what you could put, no, that wouldn't work. Hmm. I guess if you wanted to do that where you'd print a quote symbol, you'd have to do you'd have to do something like, so there's the car function. You'd have to give it the number associated with the quote, but that would not be inside of quotes.
Okay, so there isn't an instance where you can actually stick
a quote inside a quote. No.
It'll break.
It'll break, yeah.
Okay, cool.
Because what it's going to do is think that you actually have two strings.
Yeah.
Right. Yeah.
Okay.
Yeah. So, okay, which is, yes, annoying, but if you think about it, right, like, how did we do this in C, for example? If we wanted to make a string and put a quote inside of it, we had to use the, like, backslash, the escape characters or whatever it was. Same thing with, like, the end of line number or whatever. If we put a backslash in inside of a string, that wasn't the backslash followed by the letter N, or it sort of looked like it, but yeah. So, okay. Yeah, so you can assume that there's not quotes within quotes, which will mean that this carving up the string into different substrings is actually not too hard to do, because it's just, okay, have I hit a quote symbol? Just keep scanning until I hit the next quote, and all of that stuff in between, that's a single unit, and I don't have to worry about it.
You still have to convert it to like ASCII.
Well, it already is an ASCII. They're the same thing. For letters, they're the same thing. Right. Okay. After you finish processing the rest of the line. Okay, and the reason is because how long is the line now? Right, so like when I loaded in the line, how long was it? Well, it's 1, 0, space, PRI, and blah, blah, blah. So I'd have to count up that length, okay? But the print got tokenized down to a single byte, right? So how many bytes have I already put up there, including the blanks for the pointers that I haven't put values in yet? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in this case. Okay, where is the pointer going to point? To this space, right? The next byte. Okay, now we have to then think, what are the memory addresses that are going to be associated with this? So what's the very first memory address where this is going to get put? Where do the basic programs get loaded into? 01, or, well, okay, so it depends on how you want to write it, right? So they're going to be in memory address 0801. That's where the question mark, the beginning, the low byte of the pointer is going to be in that memory address for the first line. Okay, so if that's my base memory address, and I know the pointer needs to point to whatever's however many characters down the line, now that I know the length of how many bytes that I've dealt with, I just add that to 0801 and then process it accordingly. Okay, so in this case, what did we say it was going to be? If this is 01, 02, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, the next one would be where? 08, 10. Okay, which now means that my pointer is going to be 1008. Okay, and why is it in that order? Yeah, because it's stored in low byte, high byte order, even though I wrote it by hand, I write it in high byte, low byte order. Is that annoying? Get over it. Okay, it's been this way since the 80s, right? Because of how so why is it loaded in low byte, high byte order? Because the address register is a register. It's the only 16-bit register on the machine. It has to be. But when you're loading things in, it loads the low byte first, and then it loads the high byte and shifts over. Yeah. And so it's an architectural reason why it's got to be in that order. And now, if we were doing this on a 16-bit machine with 16-bit registers, we wouldn't really have this same problem because we could just load it in as one chunk. But we can't. We have to load it in sort of two separate fetches. Is that annoying? Yes. Okay. Now, that said, Here is a case where we kind of cannot assume, like, so the line numbers were a 16-bit quantity, where we knew that the upper half, or the upper half of it, the high byte, was probably both zeros, right? Because our line numbers weren't big. Here, the pointers are going to be, we do need all 16 bits for them. Okay. Now that said, for our programs, probably what can you assume that the high byte always is? 08. Okay. And that's simply because our programs are not going to be larger than 256 bytes. Okay. Or 255 bytes or whatever, right? Because we're writing, again, small programs. Okay. So in this case, we can also assume that and think of the base address as just being the number 1 rather than the number 801. Right? Okay. So does that make sense? Yeah. Okay. Well, now that I've processed that, I just do it again for the next line. Right? And then when I've hit the very final line, what am I going to tack on at the end? Well, okay. I'm going to think of it as 4 zeros. Okay, and the reason is I'm going to finish a line and that's going to have 0, 0 at the end. And then I'm going to realize there's no more lines left to do, and so I'm going to put 4 more zeros there as the end of program symbol. Okay, so maybe think of this in several stages, right? Step 1, open the files, okay, plural, 1 for reading, 1 for writing. Step 2, stick the 0801 at the beginning of the writing file. Just get that done. Okay. Step 3, take in a line, deal with it. Step 4, deal with the next line, and then theoretically continue this until you've hit the end of the lines. And then once you've hit the last line and you're done with it, then what do you tack on to the very end? 2 more bytes of zeros to null terminate the program. Okay. Okay, but does this kind of make sense? Yeah. Now, for any more detailed questions, this is going to depend on exactly which language you guys are using and which particular method you want to use and how you're thinking about carving up the string and so on, right? So that's going to vary considerably. Simon.
Could we use Excel?
Can you even read in Excel stuff? You need a CSV for Excel to read that in. Then you do comments and everything for that to read in nicely.
But it's possible.
Are you going to take the time to fix commas? And you're not even guaranteed these are in commas in the right places. Plus, there's actually commas inside of the basic code.
There could
that
be.
Could definitely fuck with it.
Right. Okay. Now, so that said, right, Excel is a perfectly useful thing for calculating. And in this case, I just used it as a place that had boxes where I could put a thing in each box and organize it. You, okay, that is true. But is that the best choice of tool for the job for programming this? Hell no. Yeah, no, don't use Excel. That's essentially the question here, right? Like, Excel is a perfectly good screwdriver. It's not a very good hammer. Yes, you might be able to bash some nails in with it, but yeah, yeah. And, or maybe another way, but sometimes you just need a shop vac. Okay. That's just what you need. Yeah. Screwdriver's not going to be a very good shop vac. Yeah. Yeah. So no, for God's sakes, do not use Excel. Yeah. Okay. Now it might be handy as like to help you like plan it out and say, okay, this is what it's supposed to end up looking like, and thinking about counting or whatever. But no, God, that would be horrible. Okay. I mean, you learned Python for a reason, right? And you learned C and assembly for a reason.
Like I've edited Excel files with Python scripts. Like you just use it as your input file, and then it writes out to an Excel file. I was just thinking of one format.
Yeah, okay. The problem with the writing out to an Excel file is that it's not in correct form, right? If you hex dump an Excel file, you're not going to get the stuff that you can then load into Vice, right? Um, yeah. Um, but see, what you just said was a little different because there you said I used Python to edit Excel files. That's a completely different thing, right? Because who's doing the programming? It's Python. Excel has just got data in it, right? You see the distinction?
That's what I was like. Can we? What I was asking originally was, can we take our hex files in an Excel file and pass them to Python that way? That's just what I was.
No.
Okay.
Yeah. I mean, you can process Excel files, yes, okay, but your source file is not an Excel file. Your source file is just a plain text thing that's got alphanumeric symbols in it that happens to be basic code, right? But it's just text, okay? Okay, so yeah. Uh, so what languages are you guys doing for this? I mean, Rippy, what are you using? Python?
Python has some pretty nice text in it.
It does, right? I figured you guys would all use Python, right? Is anybody going to use something other than Python? What are you going to use? Well, you already said what, C++, which from my perspective might as well just be C, right? Um, any other choices? Oh, well, it's
I
not
never
rockets.
formally learned that code.
Yeah. Do you think I ever formally learned Python? Do you think I ever formally learned AR64 assembly? Not formally. It was me and Rippy up in the lab just bashing stuff and figuring it out.
Yeah, no, that's
Yeah.
yes. And then you yes, that always
Yeah.
how it goes. When there's no documentation, you're on the floor trying because they've been working on things for 4 days straight.
Yeah. So,
And then you try and go back and find the documentation to see if you turn it in for your paper, and then just spend like double that time.
yeah.
How many points am I gonna lose if I don't turn it in?
None. Well, I mean, think of it.
Does it actually formally due today?
It isn't. Okay, so all right. It's due tonight, right? When is it like when is it that you can no longer submit it? 2 weeks from now, right? Right. If you don't if it works and you eventually have it in 2 weeks, you have 1 point. Otherwise you get 0 points.
It's either
Yes.
you did it and it works.
Okay. If it gets turned in this weekend and it works, great. If you turn it in and it doesn't work, what's going to happen? I'm going to kick it back to you. Yeah, I mean, this wasn't. Yeah, it's like exactly. What's the difference between this semester and last semester, though, with respect to the?
Well, assembly, you can turn in anything right for the file. Like you could literally turn assignment 00 right for the file, and the file would get points for it.
And that ship has sailed, right? Because certain students glare, 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 glare. Right?
I turned everything in assignment. I have the majority of them done. I turned in every assignment late, but only 3 in the last. There was one I submitted
Yeah.
literally the last.
Okay. So point being, right? Like, uh, now that said, and this is where I need you guys to be men. Okay. Um, unlike the assembly class, I don't necessarily know every single detail of how every single program that we're going to write is going to go, right? We could run into some snafu somewhere that we need to spend more time figuring out, okay? So, like, think of this as slightly more flexible than I'm making it out to be, assuming you guys are making honest efforts, okay? Um, because, like I said, we may run into some quirk that okay, now with this particular thing, because you guys are working in Python, that shouldn't be too quirky. But when we start actually programming like in assembly on these machines themselves, right, we're gonna run into some weird stuff. And that's okay. But we have to try first before we run into the weird stuff to then try and figure it out, right? Okay. So I mean you guys are men, so let's act like it. Okay. Okay. So right. Good? Okay. So let's get to what I wanted to talk about last time, but we didn't get to, which is fine. Um, and that is file access within BASIC. Okay. So you guys, when you did intro programming 111, right? Uh, let's see, what languages? Most of you did it by the time it was in Python. Rippy, when you took it, what was it in still? Java? Who did you? I thought you took it with Turner.
I did, but we did predominantly Java. We also used a lot of other
Okay. So, yeah. So, what was your first real language that you guys learned? For whom was it Python? Like real language. Okay. And Drake, no, that's not true. Because you guys were doing what? Robot C and Java and stuff, right? Okay. Yeah, yeah. So, Python, what else? Well, okay. I'm not counting the block languages. I mean, real language. Python, right? Scratch or Python? Okay, well, ostensibly you took a class on Python. Oh, and what was your 111? Java. Okay. Um, Java, Java. Yeah, you had the weird semester where it was like, let's look at every language, right? Okay. Um, so, but in all of those, there's a method for opening a file and writing to it and reading from it and closing them, right? And the exact details depends on exactly which language you're in, but they all have something like that, right? And my assumption here is that even if you don't remember exactly what the method is, like I didn't remember what the method is for opening a file in Python, well, if only there were a website called Google where you could type in stuff you're looking for and find documentation and read it. Wouldn't that be great? I mean, I know as men we are genetically predisposed to not read documentation, but what? It's a joke, Rippy. Come on. Yeah. You go to IKEA, you throw away the directions. Yeah. And then there's some things that are just impossible, like programming your VCR. Now, you guys probably don't know the pain that comes with programming VCRs, but because you're too young. But, yeah, well, anyway. Okay, so let me minimize this. Let me minimize this, and let's get back to the PowerPoint. Okay, so I want to talk about files and strings in BASIC and how this stuff gets stored and how we deal with it. Okay, so the first thing is that, and we've already seen this part, right? That um, the if we make a string variable a dollar sign, okay, Uh, that's the variable name A as a string. The dollar sign is what indicates it's a string. Okay. And if I say something like let a dollar sign equal hello world, I have to put the quotes there, but the quotes are not actually part of the string. Okay. Um, and and actually this is like C in assembly. Are the quotes part of the string in um, C? Let me just delete that. Because actually they're not there either, now that I think about it. Okay. Um, don't worry about it. Right. Okay. So my point though is when you print a string, okay, do you see the quotes? No. Okay. And this gets to Rippy's points about quotes within quotes. You can't do that. Okay. Which is, I guess, somewhat annoying, but oh well. Well, it's annoying in one case. It makes this other problem easier, right? So it's sort of pick your poison. Yeah. Okay. All right. And as we saw, I think before, the letter A as a variable versus the letter A $ as a variable are actually two separate objects, right? The interpreter is smart enough to actually keep track of that. Now, that said, is it a good idea to have A the number and A the string? Probably a bad move, okay? But you, strictly speaking, can, okay? Now, in C or Python or whatever, we were able to access a particular character from a string by having the little bracket with a number inside of it, right? So I could have string of I, and that would give me the ith entry out of that thing, starting with 0. Okay, and we want to be able to do that kind of character by character processing or substring processing, essentially. And there are functions for doing that. There are 3 of them, okay, and they look a little different than just putting brackets at the end. But there's some, kind of handiness to this. And they are called left, right, and mid. Okay, and one thing I like about BASIC is you see how they all have $sign at the end of them of their name. So the purpose for that is any function that returns a string has a string symbol at the end of its name. That's kind of nice, right? Because it kind of helps you understand what data you're going to be working with. Okay, all right. And the syntax for these is you pass to them the name of a string and then 1 or possibly 2 numbers, okay? And it can carve up the string into substrings. So for example, you could get the first 5 characters of a string if you wanted them using the left thing. If you use the mid one, then you can get, so the syntax for mid is mid, then what string is it that you want, comma, where's your starting index, comma, how many characters do you want out of it? Okay, so if I did mid $, I1, then it would print starting 1 character, starting with character in position I, which would be a single character. Okay, so that is equivalent to string name bracket I in C. Or, well, it's not printing, it's just generating that object. Right, so like if I said B $ equals mid $A $, comma 1, comma 1, it would put the very first letter. B $ would be a string having a single character, the letter H, from hello. Okay, and then if I did $ or $A$, comma 2, comma 1, it would give me the E. The second, starting at the second character, only going 1 character. Okay, and so this allows me to go character by character through a string. I can also carve it up into substrings if I wanted. Okay. Now, one thing that's good and also annoying, in C, what was the first character in the string? What index was it? Index 0. What is the first character in a basic string? It's indexed. What's the first index here? 1, not 0. Okay, it's 1 indexed, not 0 indexed. Whatever. Had to make a choice, right? Is that like?
It's just confusing. The assignments start from 0.
Basic is indexed starting at 1? Yeah, I know. It's almost as if this has been the bane of every programmer's existence since the dawn of time, right? Sorry, right? It's been downhill since Adam ate that apple,
Facts.
right? So, stupid snake. Okay. Yeah. Now, from a true standpoint, though, why is it actually maybe a good thing that it's 1 indexed instead of 0 indexed? You guys are used to 0 indexing. Really? Okay. In what sense? Okay, fair point, right? In everyday life that does not involve computers, you one index, right? In computers, you typically zero index. Yes? Okay. Python, C, Java, whatever, they're pretty much all zero index. Why is it maybe good that it's one indexed for this particular language?
So it's indexed to one?
Hmm?
Oh, because we're out for one. Right?
No, it's more basic than that, if you'll pardon the pun.
Oh,
Who is this language designed for?
yeah.
Beginners.
Beginners.
That's the
Really?
B in
No.
basic, right? And so yes, I think this isn't necessarily the reason, but I think it's nice that a language for beginners is indexed starting with one because that's natural, right? Everybody in everyday life starts counting with one, and so this way, yeah, it respects that. Right? I mean, how many kindergarten classes started counting at zero? If I were running kindergarten, they would, but uh, yeah. Okay. All right. So anyway, you can carve up the string with these three functions, right? Left, right, and mid. Okay. Mid is, if you want to go character by character, that's the one I would use probably because it allows you to get, to basically specify the start and end index of where you want to go, what you want. And if I wanted a single character, I could start and end. I do I comma one and then just let I iterate over the length of the string. There is a string length function, by the way, so that's nice.
What would write $sign ASI2 print? Would it print L?
No, that would print, I think, LD because right is the right hand end.
So,
Well, it depends on what I is first off, right?
oh,
Okay.
I's in mutable.
Yeah, so here when I wrote I, and I'm sorry that PowerPoint capitalized it, but I mean on the Commodore it's all capital anyway. I'm thinking of I as being something that I index through, right? That if the length of the string is 10 characters, then I would do a loop like for I equals 1 to 10 kind of thing. Yeah. Okay, so you've got those functions. All right. Now there's some other functions that we could use. Um, there are string of number will convert a number to its string equivalent, right? So you remember we were talking earlier about needing to take a string or an int and go to a string, or vice versa. We can do that. Okay, so if you've got a number and you want to go to a string, then you use the string command, right? And that's basically int to string. If you want to go string to int, I don't actually think there's a function for that, but you guys could certainly write it. Okay, and how do I know that you can certainly write it? Because you all have done it before, just in assembly, right? Okay. All right. Then there's two other things that basically allow you to get, and Rippy, I think this is how you would deal with the quote thing, is you would say ASC and then you would put a character in. Um, so if you gave it a like ASC of quote A quote, it would give you the ASCII number for the letter A. Okay, which is handy. Does that make sense? Yeah.
Yeah, you get the, just put in A, it gets you the ASCII.
Yeah. Now that said, the null string, which would be quotes with nothing inside of it, in Basic 2.0, ask of that should return zero, but it actually returns an error. But that's okay because you can always test, is a string equal to the null string, and then have an edge case for that. In later versions of BASIC, this was corrected so that ASCII of a null thing would return 0 instead of an error. Yeah, okay. And then if similarly, we've got the other direction, which is $. If you give it an ASCII or PETSCII value, it will give you the character associated with that value. Okay, now you probably only want to use that with well, in two situations. One is if you're using print hash mark, and we'll talk about what that means in a minute. And then the second is if it's actually an alphanumeric symbol, okay? Because some of the PETSCII codes, if you print them, what it actually does is change the color of the screen, for example, which may not be actually what you want, okay? So it might have sort of weird effects, but for the alphanumeric characters, those in ASCII and those in PETSCII are identical, right? The letter A is the same in both ASCII and PETSCII. The number 1 is the same in both of them. All the punctuation marks are the same, right? Which is nice, right? Because you don't have to relearn the ASCII table. Okay. Well, for the alphanumeric stuff, the rest of it though is completely different, and that's specialized stuff. Okay. But ASCII and PETSCII line up with the alphanumerics and the control characters and space and quotes and things like that, which is nice, right? I mean, that's why it's called PETSCII in the first place, right? Because it's ASCII for the pet, right? They didn't just make something up. ASCII came first, yeah. Okay, good. Oui ou non? Okay, so let's talk about file types, because there's really only 4 file types on the Commodore. Okay, and they are as follows. There's a program file, okay, which is either a basic program or a machine code program, and essentially those are hex dumps, right? They're just data. There are some details with that, and what I mean by the details are, for example, what are the very first 2 bytes of any program file? If it's a basic program file, what are they? 0108. Okay. What is that? That's the starting memory address where the thing's going to get loaded into in memory. If it's anything other than 0108, then it must be a machine code program, and the kernel will know that based on those memory addresses. So, and I said kernel, and I'm being really, kind of because it's spelled with an A, not an E. And nobody is really sure why. Supposedly there was a typo once, and then that just got propagated forever, and it's stuck now. But yeah, so the operating system on the Commodore is the kernel, not the kernel. Kernel. Yeah. Yeah. Yeah, exactly. Right. Okay. So the program file, like I said, right now all we've dealt with are the basic ones. A basic program file, which always starts with 0108 because that's where it gets loaded into memory. A machine code thing could get loaded anywhere that you want with, some limitations. And we'll obviously talk about that more when we talk about the machine code stuff. Okay. There's a sequential file, which is essentially just a plain text file. There's a user file, which is kind of the same thing, and I'm not sure why they have 2 different versions of the same thing. I'll figure that out. And then there's a rel or relative file, which is sort of like how you could do a simple database with record numbers. And I have no idea how that works because I've never used it. Okay. Now, in terminating programs, in a basic program, how is the program going to look? Each line is going to be null terminated. Each program is then double null terminated. Okay, good. Okay, modern text that's encoded in ASCII is going to probably have an end of line character 0A at the end of each line. Okay. Now, as I discovered when I was talking with Cole the other day, this could actually depend on which editor you're using. And what I mean by that is we opened the exact or typed the exact same code or text into Genie and into Atom. Or maybe it was Nano, I don't remember. Okay. And one of them did not put an end of line marker at the end of the last line. The other one did. Okay. And so that is kind of a interesting idiosyncrasy that modern text, depending on which editor you're using, it may or may not put that end of line there. How could you force it to if it didn't? Just hit enter. And so that there would be a blank line that has nothing at the very bottom. Well, with Atom, that's what it did. Yeah, it automatically had a blank line at the very end to sort of force that. Yeah, that was something I'd never noticed before. Is that kind of mildly annoying? Yes, but c'est la vie, right? Okay. Now, a sequential file, like if it's text, is going to be each line is carriage return terminated. Okay, and the difference between a carriage return versus an end of line character is 0A versus 0D. Okay, 0D is tantamount to hitting the enter key. Okay, which in most senses also creates a new line. So you see how these could kind of get mixed up. But if we were to sort of use a text editor, if you will, on a Commodore, it would be putting 0Ds at the end of every line. Okay. And how do we know that we're going from one line to the next on a program file? Well, in BASIC, how do we know we're going from one line to the next? There's sort of two ways. Yeah, each line is null terminated, but we also have pointers. Okay. In machine code, there's no such thing as a line number, right? You just have code and it just reads it in and does it until it gets to the end. Okay. Okay. So right. So this is mildly there's different terminations for different types of files and different objects. Sorry, right? That's just the way it is. Okay. Yeah. Okay. So is that all right? Okay. All right. So now the reason I mentioned this end of line character from a modern editor is because how did you produce, like for the tokenizing program, where did you write your basic source code for the tokenizer? In whatever modern editor of your choice, right? And so when you're processing this file in Python or whatever, how does Python know where the first line ends and the next line begins? What is it going to look for? Well, okay, the /n, but like that's how it represents it or possibly represents it to you. But in terms of the actual binary encoding of a file, how does it know that it's hit the end of a line? It hits this, the end of line character. Yeah, modern. Okay. If we were to write source code in a Commodore and then transfer it over, we'd have to change that to look for 0D instead of 0A, but whatever. Just, not the end of the world. Okay. Okay, so does that make sense, though? That how do you know on a modern computer if you're processing something line by line that you've hit the end of a line? There's got to be something that marks that's the end of the line, and it's 0A in pretty much every modern text editor for end of line. Okay, is that okay? Right? And I didn't make that up, right? It's just the way it is. That's just the way it is. Ba-da-da, ba-da-da, ba-da-da. Well, some things are just the same. Ba-da-da, ba-da-da. Okay. Yeah. Fortunately, my singing is so bad I won't get a copyright strike for that. So, yeah, on Twitch here, right? Okay, so good? Who know? Okay, so let's talk about the beginnings of opening and working with files in BASIC. Okay. Okay, so any program or any file type of the four can be opened in BASIC for either reading or for writing. Okay, and the syntax for this is going to be the following. Okay, if I want to write to it, then I'm going to first open. Then I have 1, 8, 4. Sorry, there should be a comma there after the 4. Let me put that in. Okay. Comma, quotes, and the stuff in the quote is going to have the file name, the type, and whether or not it's going to be a read or a write. So a W versus an R. Okay. Now, what do these numbers mean? Okay, 1, how many files can you have open at a time? In Python, how many could you have open at a time? Theoretically, as many as you want, right? In BASIC, you can only have 8 open at a time. Okay, and the way that you notate which one you're working with is by giving it a logical number, the number 1 through 8. Okay, so open 1 comma, the 1 means that this is logical number 1, and so anytime I want to write or read from that file, I'm going to use the number 1 to represent it. Now in Python, right, you would give it a name, right? This data object would be a name. In C, same thing, right? You'd have a pointer or something to it. And anytime you wanted to reference that file, you would reference that name. Here, you're going to reference that number. Okay? Is that okay? All right. The comma 8, the 8 says which device are you going to be reading this file from or writing it to? Okay? What's the default, basically? What's device number 8? Yeah, your floppy drive, okay? But it doesn't have to be. So, for example, device number 1 is the tape drive. And when I say tape drive, I mean like, you remember audio cassettes, right? Where you had to put the pencil in to, if it, did you ever?
Seen those on like
in museums? Yes. Okay, yes. So it used to be the case that you would get a program on an audio cassette. Yeah, they did. And sliced bread 2 years after that. Okay. It was amazing. Okay, so the 8 here is which device we're reading or writing to. Okay, now the devices here, and this is sort of interesting, right? That one of the devices is actually the screen. Okay, and so that's not really a file in the sense that, you know, it kind of is, but you can read data from the screen or write it to the screen, which is kind of cool. Okay. There's also, you know, there's other device numbers, but for our purposes, for most files, it's going to be number 8, which is the disk drive. Okay. Okay. And then the 4 at the end is sort of like a mode, if you will, and for writing, it's 4. I haven't found a good list of all the different sort of sub channels. 15 is where you would pass commands to the disk drive. Um, yeah, it's a little annoying because there's not a whole lot of documentation on that, but just it needs to be a 4. Okay. Um, and okay, so we can open for reading or we can open for writing. So the next thing they're open 288 new file type R would be to open another file for reading instead of writing. Okay. And this would have logical number 2 as opposed to logical number 1. Okay. Is it okay? Now, when you're finished with each file at the end of the program, you need to close them. Okay, and this is the case with the file operations in, well, pretty much any language. You open it, you do stuff, you close it before the program terminates. Yeah? And you close with the word close followed by the number, the logical number of each file. So at the end of a program that was going to read from one and write to another, I would need to put close one and close two, and then I could quit the program, and that'd be that. Okay, good. Okay, you can overwrite files if you put @0:: in front of the file name, or probably what's the easiest is to actually send a delete command. And you can do this both within a basic program and not, which is, let's say I wanted to delete the file number 1. Okay, what I would do is I would open 1, 8, 15. 15 is basically the okay, so this third number is the channel number that you're sending data to, and the channel 15 is how you send commands to a particular device. S:"file name, S stands for scratch, which is a different way of saying the word delete. You just scratch it out, okay? And so if you were to type that line, it would delete a file on a disk drive. So what it would do is open it, delete it, and close it, and then now it's gone. Okay, so let's say that we were writing a program that needed to take in some data and spit out an output. What might be a good thing to do before we actually do anything? Delete the output and then start over writing it. Okay, and why that might be a good idea is, so I ran into something when I was messing with this where I thought like I made a change, but the end of the file was still the same as it was before, and it was because it never got to that end of the file. Okay, and so by deleting it and recreating it from scratch, I was able to see that yes, in fact, my thing was working correctly. Okay. Okay, good. Right. So we can open files for reading, write. Now, when you type, okay, what are the types here? There are 4 of them. What could they be? What were the 4 file types we had? Program, sequential, user, and relative. Okay, and so you would type PRG, SEQ, USR, or REL. Okay, or actually you can get away with only typing the first letter of those. Okay, but I would type all 3 just for your own sanity. Okay. Okay, because, and maybe you can sort of sniff where this is going. Perhaps you guys will eventually write a program that takes in an SEQ and writes out a PRG. Could be. Could be coming. Who knows? Right? Okay. So anyway, but you're specifying both what type it is and also whether or not you're reading and writing and what logical number you're associating with it. Okay. So let me go to how we actually do reading and writing. Okay. The way you read is using get followed by the pound sign, and then you would append to that the number of the device that you're reading from, or sorry, the number of the logical file you're reading from. Okay, and input is, so you guys use the input command to get a string, right? For the last assignment, right? You ask the user to type something. If you use input with the hash mark, it does basically reading from a device. So the difference is get works on a character by character basis, and input works on sort of like an entire line basis, up to I think 80 characters. Yeah. Okay. And if you try to read, so get is going to return a string. Okay, it's going to be a single character string, but if it returns 00, that's what it's going to return if it's a null string. Okay, so because the null string is sort of weird, we may have to check for that in a special way. I'll show you an example later. Okay, now in the same way that I can read, I can also write. How did I write stuff to the screen? I printed it, right? So how could I write stuff to a file? I can print hash mark it. Okay, now, here you have to be careful. When we did the very first program that we wrote out of 10 print, right, what did we do? So the very first program on the very first day when I typed it in and it made stuff on the screen and you guys were like, woo, the wavy lines, right? Okay, so the 10 print program, there was a semicolon in that, okay? And anytime you use the semicolon with the print command, what it does is suppresses the carriage return, right? So if I print hello world semicolon, it's not going to hit enter after it prints hello world. If I don't put the semicolon, then what happens? It's going to carriage return and go to the next line. So like if I print hello and then print world, what would I see on the screen? Hello, then world on the next line. If I put a semicolon, it would be all together. Exactly, as opposed to doing it one character per line. Okay, so which depending on what we're doing, we may want either one, right? So this is why having the option is nice. If you include the semicolon, it's going to suppress the carriage return. If you do not, it will not suppress the carriage return. If I'm trying to write to a file, I probably want to suppress the carriage return because I don't want to have a carriage return after every single letter. That would be annoying. And I made that mistake once. And it was like, where the hell are all these carriage returns coming from? And then I was like, oh, right, I forgot a semicolon. Okay, so you can read and write using these methods, get or input. Mm-hmm. You have something to like to share with the class? Okay, so we'll talk about this one more at the next time. But let me just sort of give you the highlights for this. Okay, I wrote a program that is capable of copying one file to another. Okay, and now maybe I did so in the most inefficient method possible. Okay, but what is it basically doing? It's going to open up a program file, and I just picked program file since that's what we've been working with. Okay, and I open one for reading and one for writing. Okay, and then what I'm going to do is get a character from the read file, and then I'm going to print it, okay, to the write file. And this ST, there's a status thing. I'll tell you guys what that means later. But basically, I'm only going to print it if I'm not at the end of the file. And if I am, then I'll print it. Okay. And if it's the zero character, then I'm going to print the zero character. Otherwise, I'm going to terminate. Okay. And so, sorry, that's not what I meant to say. Um, uh, yeah. Okay. We'll talk about what this status thing means later. Okay. But then what I'm going to do, and Rippy, this gets to the issue about the null string, is if the character is the null string, then I'm going to print the character number 0. But I can't just print null string. It'll give me an error. Okay. Whereas if it's not equal to the null string, okay, how do I do not equals, by the way, in BASIC? How would you do it in C or something? Yeah, you do exclamation point equals. What is it in BASIC? Greater than less than for not equals. Okay, just interesting. Okay, whatever. So, yo, yeah, well, yeah, that's what I meant. But I can't do that, actually. Well, actually, yeah, Okay, well, getting old sucks. Okay, yeah. Okay, and then I loop through this basically until I hit the end of the file. Okay, all right, we'll talk more about that next time, and keep crack-a-lacking on your tokenizers, and see how those are coming, and yeah.